Okay, in the continuation of our discussion on triangles, let's talk about postulate 13, which said that if two sides and the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, then the triangles are congruent. We name this one as side, angle side, congruence postulate. Okay, or the side angle side, SAS congruence postulate. Okay, the idea of included angle here is that it means that the angle, okay, the angle is between the two sides. That's why it's called included angle. Okay, so in this case, if we have triangle, let's say we have two triangles here, and let's name this one as triangle DOG, and let's name the other triangle as CAT. Okay, so let's mark the congruent parts. Okay, so if DO, segment DO is congruent to segment CA, and segment CP is congruent to segment DG, okay, then triangle DOG is congruent to triangle CAT by SSS, or SAS rather, side angle side congruence postulate. Let's have an example. So given that segment PN is perpendicular to segment MQ and segment MN is congruent to segment NQ, let's prove that triangle PNM is congruent to triangle PNQ. So before we proceed with the proof, let us first illustrate our given. So we see here that let's draw first segment MQ. This is segment NQ, and according to the given that PN is perpendicular to NQ. So let's draw segment PN here. PN. Okay, and since PN is perpendicular to NQ, then we'll have the perpendicular symbol. Okay, and let's connect point M and point P to form a triangle, as well as point P and point Q. Okay, now one of our given suggests that segment MN is congruent to segment NQ. MN is congruent to segment NQ. Okay, now let's show that triangle PNM is congruent to triangle PNQ. So again, our proof would have our statements and our reasons. Okay, so number one, let's have again our given, our first given. It is said that segment PN is perpendicular to segment NQ. Okay, and this one is given. Okay. Now, so we have learned in chapter 1 that whenever we have two segments or two lines as perpendicular, then a right triangle is formed. Okay? So we can say that angle PNM and angle PNQ are right angles. Okay? And that is based on the definition of perpendicular lines. Okay. Now, so for our next statement is that we already know that angle PNM and angle PNQ are right angles. Then definitely we can say that the measure of angle PNM is equal to 90 and the measure of angle PNQ is also equal to 90. Okay? And that is definition of right angles. That's correct. Okay. Now, so we'll draw our next statement to statement number 3 because we can see here that we have 3 quantities and therefore we can say that the measure of angle PNM is equal to the measure of angle PNQ. Okay? And the reason is the transitive property. Okay? Property of equality. Okay? Next. So since the two angles, we already have shown that the measure of the two angles are congruent, then equal rather, then we can say that angle PNM is congruent to angle PNQ. And that is the definition of congruent angles. Okay? And now, so since we have already established that the two angles are congruent from our given, and let's draw another information from our given, which is number 6, segment MN is congruent to segment NQ. Okay? And that is our given. Okay? Now, so we can see here as well from the figure that segment PN is equal to itself. So we can say that segment PN is congruent to itself. That is by the reflexive property of congruency. Okay? Reflexive property of congruency. So we are able to show that this is already congruent, and therefore since we have already congruent angle, this one is congruent side and another congruent side, and we know that angle PNM and angle PNQ are included. So therefore, we can say that, we can now conclude that triangle PNM is congruent to triangle PNQ. And the reason is by the Side angle side congruence postulate. And this ends our proof. Okay? Next, let's have another postulate. It says here that if two angles of one triangle are congruent to the two angles and the included side of a second triangle, then the triangles are congruent. And we call this one as the angle side angle congruence postulate. Okay? The angle side angle congruence postulate. Okay, so notice that we have here the included side, meaning to say that the side, okay, the side here is between the two congruent angles. Okay, so if we are to illustrate the figure, let's draw first two triangles. Okay, let's name this one as triangle PET, and then let's name the other triangle as DOG. Okay, so according to the given postulate, if angle, let's say angle P is congruent to angle D, because angle P corresponds to angle D, and let's say angle T, okay, is congruent to angle G, because angle P corresponds to angle T, then and before we proceed with then, we are still missing another part. So what side, okay, is included between angle P and D and angle T and G? Okay, it is segment PP, okay, is congruent in segment DG. Okay, segment DG, then we can say that triangle PET is congruent to triangle DOG by the ASA congruence postulate. Okay, so let's have another example. This time we already have our figure. So given that segment AC is congruent to segment TC and angle 1 is congruent to angle 2, let's prove that triangle ACE is congruent to triangle DCB. Okay, and what we have here is an example of an overlapping triangles. Okay, overlapping. So when dealing with overlapping triangles, you need to be very critical when it comes to the parts. Okay, you have to take note of the parts so that you'll be able to prove which part, or we have to establish first which part are corresponding to the other part of the triangle. Okay, so we have shown here that it is said that segment AC, the longer leg, segment AC is congruent to segment BC, and then angle 1 is congruent to angle 2. Okay, so let's prove that triangle ACE is congruent to triangle DCB. This one is actually easy, so the proof of this is easy. Let's have our proof. So that these are our statements and these are our reasons. So number 1, from the given, we have already know that segment AC is congruent to segment BC. Okay, and I can also write that angle 1 is congruent to angle 2. Okay? These are the given. Next. So to prove this triangle to be congruent, we need to show that angle C is congruent to itself. Okay? So angle C must be congruent to itself. Angle C is congruent to itself. And the reason to this is because of the reflexive property of congruency. Okay? So notice that we already have an angle here which are congruent, an angle here which is also congruent, and then we also have a side here. And notice, based on the given figure, that the side which is AC and DC are included to angles 1 and angle C, as well as angle 2 and angle C respectively. So therefore we can now say that, we can conclude already that triangle ACE is congruent to triangle DCB. And the reason to that is because of the angle side angle congruence postulate. Okay?